My plan is to do 2 video segments dealing with some subtle issues in mechanism design, and particularly the parameter being out of range, or resetting the zero of a prismatic joint, or some issues related to rules, which we're going to discuss to some extent. Now, this resembles the problem that we had in chapter 2. So we have a block traveling along this track. There is a propeller here, which I'm going to hide for now because it's not going to be participating, at least in this particular video segment. Now, the track is 20 inches long altogether. Now, this point, the point that you see here in the middle of the track, this is the global coordinate 0, 0, 0. Okay? Global origin. 10 inches to the right, 10 inches to the left. And I have put a marker here which looks like magenta, and this is at the location which is lined up with 0, 0, 0. In other words, if you look at this, the x of this magenta surface, or the marker, is x equal to 0. Okay, and then these are every 1 inch apart, so that I know exactly what I'm doing. Okay, so remember, there are 2 ways of doing the mechanisms. One is create assembly constraints, and then sufficient assembly constraint, and then moving into the DMU kinematics and use the magic wand to convert the joints, the assembly constraints to joints. Now, certain joints cannot be done like that, but prismatic, revolute, and things, cylindrical, planar, the basic ones can. So that's the route that I'm going to take. That's the route that I'm going to take, and but I would like to make sure that this point, see that this point is lined up with, is on that line, for example, or at least lined up with that line. So let's see now. We are in assembly design. Right now, if you look at it, this is kind of away from it. Either that point or this line is coincident with this. So let's do that, and then I'm going to delete it. So coincidence between this line and this line, which incidentally belongs to the track, and there we are. So now they're lined up, and I'm going to deactivate this particular constraints, or I can delete it. I can deactivate it or delete it. Okay, now we're going to switch to DMU kinematics. We are there. So we're going to try to create a prismatic joint. So the prismatic joint, notice that right now there is no mechanism here. Right now there is no mechanism, and we need to create one. It's called mechanism 1. So the lines are, you can now select this line and that line and this plane and that plane. And when I close it, the bar is located, this bar is located like so, and this is a prismatic joint with a single degree of freedom. Okay, now I cannot simulate these things unless I fix something. Remember that mechanism is a collection of parts, which really is not a mechanism. It's called a kinematic chain. A kinematic chain is a bunch of parts put together due to some joints, but this is totally useless, okay, unless you fix something. So here is the anchor. Click and fix the part which is the track. Okay, now I don't need these constraints. I'm going to hide them. All right, now the degree of freedom is 1. We know that because it's just a position along the length. If I double click on this prismatic joint, and select the make it length driven, which means I issue a command. First of all, notice that there is a blue arrow here which says that the block moves to the right, or I want it to go to the left, okay, in the positive x direction. Now the range is from minus 100 to 100. That means I can use the sliding bar to move this thing anywhere between 100 and minus 100, okay. So let me actually make it from minus maybe well, actually, you know what, let me make it from 0 to maybe, okay, minus let's see now, minus 5 to 15. Sorry, minus 5 to 10. That's what I meant. Okay, mechanism can be simulated. First of all, what is this business of minus 5 to 10 that I made? Well, if you click on the simulation with command, notice that the range of motion that I specify is from minus 5 to 10. So if I drag this thing to minus 5, it'll go to the right to location minus 5. And if I drag it to the right, it'll go to the position 10 on the left. If I reset it, it goes back where it was. Okay, now notice that if I did try to change this range, for example, minus, just hypothetically, minus 10, okay, it's going to go from minus 10 to 10, minus 10 to 10. Reset. Very good. Now one more time, if I click on this thing, you see a number down here. This is called spin box increment, and this is how big a jump these things make. For example, see, it says minus 0.5, right? If I close this, right now I'm sitting at 0 at 0. So if I put a 0.5, if I increase this thing, right now it's at 0. If I increase it, it increases by 0.5 units. So see, 0.5, 0.5, 0.5, in other words. Now if I go here and change this to, for example, 2, and I increase it, it's going to increase by 2 units. So it's going to go to location 3.5, another 2, etc. All right. So you know exactly what this thing is. Let me put it back to put it back to to 1, for example. I'll put it to 1. Okay. So notice that here, if I bring it down, it's going to go to 6.5. 6.5 moves by 1 unit. So you know that spin what was it called? Spin box increment is. Fine. Reset, and it goes there. Okay. Now, let's do the following. So let's go here and change the range from, let's say, I don't know, maybe let's make this thing, we leave that thing as 10, and we make this thing a 3 to 10. We say okay. Notice that it did not change. See, I did try to change it. I did try to change it from 3 to 10, but it didn't change. The question is why? The reason is that if you look at the prismatic joint, the range was from 0 to 10. Now, this is the range of motion that I specified, 0 to 10. And if I want to change it to 3 to 10, I can do it from here. But then it says the following, 3 to 10. It says that, look, you want the range of motion be 3 to 10. This is 3 inches in millimeter and 10 inches in millimeters. But what it's saying is that, wait a minute, the thing that you want to move, this block, is not in the range of 3 to 10. Therefore, it's not going to change it for you. This has to be already in the range that you specify here before you can change. For example, if I say from Obviously 0 is going to work because it is sitting at 0, no problem there. We know that. Okay? And you click on it again. You go there, 0 to 10, no problem. Double click on prismatic joint. If I change this thing from -3 to 10, there is no problem because -3 is on this side, 10 is on that side, and that is already in that position. See? It allows me to close it. And if I click on this, I can change it from -3 to 10. Reset, close. Now let's try one more time. Remember, the range -3 worked, no problem. But if I go there and try to make it from, let's say, again, from 5 to 10, it's going to refuse. Because it says, you want me to restrict the motion from 5 to 10. But this block is not in that range, therefore, I'm not going to do it for you. You can make it from -5 to 10, there's no problem, because the block already sits in the range that the new range that I specify. See? No problem. Reset. Okay. All right. So let us go back. Let us go back and change the range to 0 to 10. It's not going to complain because this is already setting at the position 0. If I had done it 1 to 10, it will not. Okay. Now, so that's the first thing that we noticed. I already suggested the video clip for you, which talks about two boxes, two messages, and this was one of them, but I'm discussing it in more detail with you. Now, let us do the following. Let us go and put some physics behind the problem. So we're going to say f of x, mechanism, right here, mechanism, take this and say add a formula. And we're going to give this thing a velocity of, let's say, 1 inch per second. So mechanism, the command, the length equal to 1 inch over 1 second times time. Okay. And we close. So let's do simulation with command. Simulation with command, and do a 10-second default simulation. So after 10 seconds, this is going to travel by 10 inches, and it's going to end up at that last marker. You can see this. 1 inch per second times 10 seconds, and it's going to end up there. Great. Rewind. Close. Okay. Now let me do this thing. Let me do it again. First of all, we're going to check something. 10 seconds. No problem. You can see that. And now let me close this. Click on f of x. And look at what happened here. It shows you that the location, the value of that length currently is at 10 inches. You can see that. Okay. Good. Close it. Rewind. Now rewind means that you click on simulation with law, with simulation with laws. Rewind it, and it's there. Let me do a simulation. Let me move this thing by in 2 seconds, for 2 seconds. So let's do that. 2 seconds instead of 10 seconds. Okay, so if I play it, then it's going to go to 2 inches and it's going to stop. Let me actually make it 3. How about 3? Make it 3. Okay, so it's going to go by 3 inches and it's going to stop in that location. That's a no-brainer. We understand. And I close that. Okay, when I click on this guy, when I click on simulation with loss, okay, I can rewind it. Let me do it. Let me play it again. Just going to put at 3 inches and close. Okay. Now suppose I wanted to make this thing 5. In other words, the duration of simulation to be 5. If I click on this and make it a 5 and I close it, okay, when I play it, it starts from this, the original location, and it goes by another 2 seconds. It goes to 5. So the 5 that you put in there, already 3 seconds of it was accounted for, and I'm doing another 2 seconds. Okay, so let me move it to 3 seconds. Move it to 3 seconds. What I meant by that was, let's go to 3 second simulation. Play it. It's going to stop at 3 seconds. 3 inches. Good. And I close it. Now suppose I want to measure my time from here. In other words, I don't want this to correspond to the 0 position. I want this to be the 0 position. So the question is, how do I do that? If you double click on this command, you see that? I expanded the command branch. If I double click on this, there is a box here which says reset to 0. Reset to 0. If I click on this, see right now it says the command value is 3. If I say reset it to 0, that means that the 0 second starts from here, or the length along the prismatic joint, its 0 is there. It's no longer the original position. So we say, okay, so let's try it. I go to simulation with loss. Now notice that it jumped to this. That's okay, rewind it. It starts at this location, and let me change this thing to 5. So the 5, you will see that it's going to start from here and it's going to go another 5. So before, if I said 5, it will go an additional 2 inches, but now it's going to go an additional 5 inches. Okay, so let's see. Starting here, move by 5 inches. 1, 2, 3, 4, 5. If I rewind, of course, it's going to go back to right here where it was. So let me rewind it, and I play it again. Okay, as I expected. And by the way, if I close this, if I close that, and I go to f of x, it'll give you a total of 8. Well, it won't give you 8. That's my point. It won't give you 8 because the number here is actually the command value. It's not the distance from the 0 position. This was the 0 position. 0 position means global. What I mean by 0 position is global coordinate, global origin. Here, the distance to the global origin is 8, but that 8 is not the command value. It is the coordinate, and this is the command value, which is 5. Okay, close. Now, suppose I want this to be my 0. Double click on this thing, 0 time. Right now it's 5. I reset it to 0, and I say OK. Okay. So, for example, suppose I say travel in this direction by let's see, where are we here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we go here. I go to my law. First of all, since I wanted to go backward, I put a minus 1 here to go backward, and I wanted to go by 10 seconds. 10 seconds. Change this thing to 10. Okay. Rewind. This is where I was, right there. And I say go away 10 seconds. Remember, I reset it and then change my time. And when I rewound it, it ended up at this location here where it was. And if I go 10, it's going to go 8 units this way, another 2 units, and they'll end up at location. Think about it as either -10 or we'll see. It'll go past, it'll go past, it'll go past, it'll go past, and there we are. If I close this and check the value of the command, it says -10. Close. If I want this to be my 0, double click on this, reset. So zero time is going to be measured from here. Okay. And if I wanted to go in the opposite direction, so one way is to go back here. First of all, change the velocity to plus. Say okay. And let's say that I say a 2 second. Go 2 seconds. Now don't let it bother you that it goes there. No problem. Remember, it was sitting at this location. It was sitting at this location. So I'm going to change this thing to 2. As soon as I say okay, it goes back where it was. Okay? And rewind it, it's going to go back where it was. Rewind it, there. And play it for 2 seconds, it's going to end up at this, on the left side. So we've got to be a little bit careful about that business of where there's a difference between the command value and the coordinate. And you've got to be taking into account that fact, and I will move on with the rest of this problem in the second video clip. I'll bring in the propeller, install it on top of that, and then we do a second. I don't want these videos to be too long. This is where I'm going to stop this thing here. So this is video segment 1 of either 2 or 3. We'll find out. Rewind. Okay. And exit.